Hello and thanks for joining me. I recorded this video to give a walkthrough of how I use components of the Elastic Stack to supplement and search my RITA network threat hunt findings. RITA is an open source network analysis toolset capable of finding command and control beacons or DNS tunneling inside your network traffic. RITA consumes Zeek logs, and later in the video I'll show you how we generate those logs. One way that RITA provides results is with a CSV standard output. In order to enrich and search our RITA results, we need an Elastic Stack. I decided to use a pre-built distribution to simplify this deployment. SoftElk is a virtual machine distribution which is provided as a community resource but is covered in depth if you attend one of the SANS courses listed on the GitHub page. In order to run the virtual machine, I downloaded and installed VMware Player. VMware Player is a free application for interacting with VMware virtual machines. To get SoftElk up and running, I downloaded the VM zip file. Then I extracted the files to a directory on my host where the virtual machine will be kept. Once extracted, I right-clicked on the virtual machine config file, which ends in .vmx, and chose to open it with VMware Player in order to boot it up. When starting the VM for the first time, VMware Player will ask if we copied or moved the virtual machine, and in most cases you'll select I copied it. Once the VM has started, log in with the default credentials of elk_user and password of forensics, all lowercase, and download the latest patches using the yum update command. After the patches are complete, reboot and move on to the next portion of the configuration. Now that our VM is back up, let's connect to it via SSH using PuTTY. We will clone the RITA repository using the git clone command followed by the GitHub URL. Once complete, we move into the RITA directory and run the install script as root. Allow the script to run, accepting the defaults through the prompts. In the background, I've connected to the IP of our SoftElk VM over port 5601 to load the Kibana interface. Although Kibana is up, we still need to ingest some data into our Elastic Stack before we can make use of it. After the RITA install has completed, we need to edit the ritaconfig.yaml file in order to specify the internal networks so RITA can work its magic. Uncomment the appropriate networks for your setup or just follow what I do. We'll confirm that the RITA install is ready by running a quick config check. In order to prep Logstash, our tool for ingesting and enriching logs, I downloaded my sample config file from the RITA Elastic Supplement GitHub and moved it into the proper directory before restarting Logstash and reloading the new file. Let's grab some sample data and run it through our freshly installed toolset. Active Countermeasures has great resources for this, so let's grab the files directly from their website. Go ahead and create a couple folders for our lab data and then download the files using wget. The first file contains a set of pcaps which will replay through Zeek in order to generate the logs that RITA needs for analysis. The second sample is some raw Zeek logs that have already been generated, of which we will also analyze with RITA. The next step is to replay the pcaps into our bro Zeek tool using bro-C to ignore checksums and -R to replay the pcap file. Our Zeek logs will be placed into the directory that we are currently working in. Notice how I forgot to source my Etsy profile and my bro command didn't work, so don't forget to do that if you forgot after you installed RITA. Execute the RITA import command and specify the log directory and database name for each dataset. Let's prepare the output directories and start the output files with the touch command. We will append our RITA results to each file so that Logstash recognizes the new data and ingests it. Prior to ingesting our RITA results into the Elastic Stack, we need to complete a few final steps. One important step is to create the Elasticsearch index template so our RITA data can be properly typed and searched upon in Kibana. Without this, we wouldn't be able to sort our results or do any of the other cool things in Kibana that I'm about to show you. To load the Elasticsearch index template, use the DevTools section in Kibanas. Use the API put method and include the JSON, which can be found in the RITA Elastic Supplement GitHub. We also need to load our Kibana saved objects, which include a pre-built dashboard, visualizations, and saved searches. You can do that by saving the contents of the Kibana objects JSON file to your local host and uploading it to Kibana in the Management Saved Objects section. When I tried to download this file directly, it didn't work, so I just created a new file and copy-pasted the contents. Here I am importing the saved objects and then viewing the RITA dashboard. Now that our data has been ingested and analyzed with RITA, it's time to see some results. We output the results of the RITA show beacons and show exploded DNS commands into their respective text files. Returning to the RITA dashboard, we can see that results have started to populate. Links to saved searches let us drill down on intel like beacons. Our beacon results are automatically sorted by score and connection count. We can expand these events and view additional information such as GeoIP location and autonomous system owner information. A link to apility.io lets us pivot to a secondary data source of further information. This can easily be customized to a site of your choosing. The exploded DNS results provide a count of unique subdomains per domain and a count which indicates how many lookups were done. These stats help us identify command and control over DNS by highlighting the anomalies. HonestimNotEvil.com has a significantly higher number of subdomains, which is suspicious and should be further investigated. You may find that RITA will provide some false positives. Destination IPs can be tagged to indicate that they should be whitelisted. Take a closer look at the Logstash configuration to better understand how that works. I hope you all appreciated this video, and make sure that you support active countermeasures and Black Hills Information Security, as they're the ones responsible for creating and maintaining RITA.